Today we're going to take a look at factor by grouping. So factor by grouping is used when we have four terms. So let's look at this first example, xy plus 3y plus x plus 3. So what we want to do is actually, I'm going to rewrite this so I could space it out a little bit more. So we want to group and then factor by grouping. So we're going to group the first two, and then we're going to group the second two. So the second two terms, you want to be careful here on how you write this out. I'm going to group this. So it's these two factors here. And then we look at each parentheses, each group that we just put together, and factor to see if there's anything that we could factor out. So in this first set, I have xy plus 3y. What could I factor out? I could factor out a y. So I'm going to factor out a y from there. And then I'm going to divide both terms by that y. So the y's cancel, the y's cancel. So then I'm left with x plus 3. Cool. The second one, I have x plus 3. I don't have any GCF. I don't have an x in both terms of x and 3. I don't have a constant. Like if this was like 6, I could take out a 3, but it's not. It's just x plus 3. So I can't take out anything. So I need to take out something, though. That's just going to be a 1. If you don't have anything to take out a 1, and then write down what it was. So x plus 3, because we took out a 1. And then what you should notice is this. Look at this. X plus 3 and x plus 3. They have the same terms, x plus 3 and x plus 3. So now we're going to factor out that x plus 3. So I'm going to take out x plus 3. And what ends up happening, since I'm taking out x plus 3, we divide both terms by x plus 3. The x plus 3's cancel, leaving me with just y plus 1. Because again, this process was this. I took out x plus 3, so I divided both terms by that x plus 3. X plus 3's cancel, x plus 3's cancel, leaving me with just that y plus 1. But I factor out the x plus 3, so I want to write that as x plus 3 times y plus 1. Factored. Done. Cool. The next one, 10x to the third plus 4x minus 15x squared. I'm going to write it out just so I have a little bit more room. So in number 10, first thing you always want to try to find is a GCF amongst all four terms. Like that might make things a little bit easier. So if I have a 10 and a 4 and a 15 and a 6, I don't have anything that I could factor out on all three terms. And then I have x to the third, or all four terms, x to the third, x to the first, x to the second. Then this one doesn't have an x. So I don't have anything that I could factor out in terms of the variable from all four terms. So I don't have a GCF amongst the original problem. So now I want to look to factor by grouping. So I'm going to group the first two. Here's where you want to really be careful with the next group. And I mentioned that in the last one, but it didn't really play out because this was plus in between my two groups. But since this one is minus, when you group this, you could do two things. You can group it like this, where you put the parentheses in front of that minus sign. Just know that there are some cases where if you do that, then you're creating a multiplication question, because then it's this times this. Like it becomes like two binomials. But when you do this, though, you understand what you're doing. You understand that I'm just grouping this with the minus sign in the front because then it's a leading negative. So you're not interpreting as two binomials being multiplied together. But I'm just letting you know that if you look at some explanations, some will say like, oh, you can't do that because then you're creating two binomials because you can't just put the parentheses there because then it's the first term times the second term. But you know what you're intending to do. But here's a way that you can kind of get around that. If I have a minus between the first group and the second group, I could do this. I could change this to plus and make this negative. So I'm just flipping the subtraction to addition and then just tacking on that negative there, and then look what ends up happening. And then I have the negative on the inside, plus sign in between, no issues there. So we're going to group the first two, group the second two, and we're going to look to factor. So factor each. I have a 10 and 4. I could take out a 2. So 2 goes into 10, 2 goes into 4. And then I could take out an x, because x and x to the third have at least an x in common. So I'm going to take out 2x. 10 divided by 2 is 5. X to the third divided by x to the first is 3 minus 1, which is 2, so x squared. 4 divided by 2 is 2. X is canceled, so 5x squared plus 2. Second term And you do want to make sure that negative, since it's minus, you want to make sure that that's in there. That if you, even if you did write it like this, like even if you just put the parentheses around there, so like your other one, you got to make sure that negative's there in some way, because you want to take out a leading negative. And if you don't take out a leading negative, this is not going to work. So if I take out the leading negative, I'm going to have negative. What am I taking out though? 15 and 6. I could take out a 3 because 3 goes into 15, 3 goes into 6. So I'm going to take out 3. And I can't take out anything with the x's because this is x to the second. This doesn't have an x. So I'm just taking out negative 3. So I'm dividing each term by negative 3. Negative 15 divided by negative 3 is positive 5. And then we're still left with that x squared. Negative 6 divided by negative 3 is positive 2. Look what ends up happening because I factor out that leading negative. I get the same thing, 5x squared plus 2. If I didn't do that, my signs would be flipped, and it wouldn't be the same, so I wouldn't be able to factor from there. But we're trying to generate these scenarios where we could factor, so I can take out 5x to the second plus 2, and then I'm left with the 2x minus 3, so a factor of 2x minus 3. And that is done. Cool. Next one, number 11. Let's look for a GCF amongst the original problem. I have 12, 20, 9, and 15. So 12 and 20, I could take out a 4. Let's see if we could keep going. I could take out 4 does not go into 9. And then there's nothing else. So I can't take out anything amongst the 12, 20, 9, and 15. Let's look at the variables. X to the second, x, x, no x. So I can't take out any x's. If this last term had an x, then yeah, I would be able to, but it doesn't, so I can't take out anything amongst all 4. And then we have y, 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 but this one doesn't have a y, so I can't take out any y's. Okay, so nothing to factor out from the beginning. Let me just rewrite my question here. I'm going to group, so group the first two, group the second two. We don't have to worry about any sort of signs there. And then 12 and 20, that can be a 4. I can take out 4, because 4 goes into 12, 4 goes into 20. And then I can also take out x, because they both have at least an x, so 4x. 12 divided by 4 is 3. X squared divided by x to the first is 2 minus 1, which is 1, so x minus 20 divided by 4 is 5. And then I took out x, x over x cancels, so leave me with just y. And then the second term, I could take out 3, right? Because 3 goes into 9, 3 goes into 15. So let's take out a 3. What else? I cannot take out an x because this term doesn't have an x. I can take out a y, so let's take out 3y. Dividing both by 3y. 9 divided by 3 is 3. Y's cancel, leaving me with just x. 15 divided by 3 is 5, so minus 5. And then y squared divided by y to the first is 2 minus 1, which is 1. So y to the first. And boom, 3x minus 5y, 3x minus 5y. Super cool. So I'm taking out 3x minus 5y, and I'm leaving 4x plus 3y. Fun one there. This next one looks even better. Let's check this one out. 6x squared minus 3xy minus 30x plus 15y. So I'm thinking we could take out a 3. 3 goes into 6, 3 goes into 3, 3 goes into 30, 3 goes into 15. So I can take out a 3. Can I take out anything else? This is x, 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 no x. And then y, no y, no y. So nothing there. So let's take out a 3 at least, just to break this down a little bit. So I'm going to take out 3 from everything. I'm going to be left with 6 divided by 3 is 2, so 2x squared. 3 over 3 is 1, so I'm left with minus xy. Minus 30 divided by 3 is 10, that's just x. And 15 over 3 is 5, so plus 5. Y, don't forget about that y. Okay. Nice. I was able to factor out a 3 there. Now, we still just take the original 4 terms, and now we're going to factor by grouping again. You could ignore the GCF, but just make sure you bring that down to the end because that GCF needs to be part of our answer. Like, for example, if I pulled out a GCF of 3 on the last one, I would just have a factor of 3 times the after the grouping. So I want to make sure that 3 is there. But I want to group, so I'm going to have these first two. And then we have that second term. Now notice it's a minus, so if I don't know which method you prefer, but I'm going to do this and then just tack on the negative inside there. So here we go. I'm going to ignore the 3 for a second. On the first term, I have 2x squared minus x, y. I can only take out an x, so I'm taking out an x, so that's just going to be 2x minus y. Second term, I could take out the leading negative, first of all, leading negative, and then second of all, I could take out a 5, so negative 5, and that's going to leave me with 2x minus y, because 5 divided by negative 5 is negative 1, and then I'm still left with that y. And look at that. 2x minus y, 2x minus y. So I'm going to take out 2x minus y. And don't forget about that GCF we factored in the first place. Left with x minus 5. And then I want to bring down that 3. There is my answer. So a lot of moving parts there. We factor out the GCF of 3. And then we factor by grouping, making sure that this negative, we have to include that some way. So I originally had this minus 10x plus 5y. So if you grouped, you could have done that. But like I said, sometimes some people get a little upset with that method. So I'm just showing you some different looks to that. Okay. Well, there it is. That's factored. So that was factored by grouping.